Okay, just a quick run through on some of these questions. I'm going to start on just a quick run on some of these questions. I'm going to start on question 8. So they want you first of all to sketch 2x plus 1. So if you put in x equals 0, you get y equals 1. That's 1. If you put in y equals 0, you get 0 equals 2x plus 1. So x is minus a half. It's minus a half. That means that this curve goes through there. Also, show on your sketch that where y equals 1 and y equals minus 1. Y equals 1 is there. Y equals minus 1. So minus 1. When y equals minus 1, that would be somewhere here. But if y equals minus 1, that means minus 2 is 2x. That means x is minus 1. Okay, so now we want to draw 1 over f of x. So if you want to draw 1 over f of x, this is where the intercepts are. The reason they wanted the 1s is because when you flip the 1s, it doesn't change it. So where that intercept is, that's actually where the asymptote is. So that's like a dotted asymptote. And then through here, you've got to flip everything. So just flip it. And the red curve is what your curve looks like. Write down the equations of the vertical and horizontal asymptotes. So the vertical asymptote would be when x is minus 1, and the horizontal asymptote would be this line here, which is the x-axis, which is when y equals 0. It's D. Question 9. Okay, y equals 2x squared minus 8. So 2x squared is like that, and it's kind of very skinny. Minus 8 would be down there. So that's 2x squared minus 8. Okay, and that's 0. Sketch that curve. So it says sketch that curve showing x and y intercepts. So just get rid of some of this other stuff, so it's easier to do. So sketch the curve showing x and y intercepts. So it's going to come down here to minus 8. Now, when y equals 0, 2x squared minus 8 equals 0. Take the 2 out, so x squared minus 4 equals 0. X minus 2x plus 2. So that means x equals 2 and minus 2. 2 and minus 2. Okay, that's A. Alright. Show on the sketch where y equals 1 and y equals minus 1. Y equals 1 when 2x squared minus 8. Now, I'm not going to actually find the exact thing, but y equals 1 is about there. And y equals minus 1 is about there, and that's minus 8 there. Okay, so we want to sketch 1 over f of x. So this is where the asymptotes are. That's at the intercepts, and then these all flip. Flip, and then that flips. The reason they want the 1 is because that's where it stays the same. Okay, looking at this one here. So question 9's done. Sketch the reciprocal function of each of these curves. So you go to the intercepts, that's where the asymptotes are, and then you flip the curve. Okay, now they put that value in there, that's at 0 minus 8, so it comes minus 1 on 0. So you flip all the intercepts as well. Minus 1 on 8, sorry. So this one here looks like this. Alright, if you have this point here, which was 1, 4.5, when you flip 4.5, so 4.5 equals 9 over 2. When you flip that, you get 2 over 9. So that's actually down there. These are your asymptotes, and this actually gets flipped, and that gets flipped, and that gets flipped. Okay, find the equation of the vertical and horizontal asymptotes of these. Alright, so x minus 3. Okay, so if you're going to find the asymptotes on these, you could actually sketch this using this technique where that's y equals x minus 3. If you did y equals x minus 3, that would be minus x minus 3. And then flip it. So that would be your thing. That would go like that and like that. And when 2 is just going to affect the steepness. So it's 2 times like the reciprocal. Okay, so now when I look at this, I go, alright, looking at that point there when x equals 0, y is minus 2/3, because you just put it into your function. Okay, and that's my curve. You could also say it's just like a normal hyperbola shifted to the right 3, so that means that's why your asymptotes at 3, and then you just you draw your sketch, which is here and here. See? I've shifted to the right 3. Okay, in part, I'm not going to, those ones are pretty tough, but we might just have a quick look at a couple of them. I think they're going a little bit beyond the syllabus though. The vertical asymptotes are always when the denominator equals 0. So it's when that equals 0. So 2x equals 3 over 2. Now I think that's going a little bit out of the syllabus. But this one here too, we're going to leave number 12, and I'll come back and I'll do those with you later. So leave number... Okay, so looking at this is more like I want to look at. So if you look at the first one, what have we got there? We have this line here, and we have a parabola like that. Okay, so basically if I'm adding those, like if I'm doing A, where I'm doing f of x plus g of x, that means when you add 0 and 0 you just get 0. When I add this y value and then I add that y value again, I end up with something that's bigger. It almost doubles, so it's down here. So that's my first point. If I add this y value, that little bit, and then I add this one, then I end up with a really one about there. So you're just adding on a little bit. When I add, until I add to there and I get 0, so that's going to go down there. If I add on here a little negative with a big number, that means that it's going to take it away, so it'll actually end up being like somewhere there. That's coming down there now. And then I'm adding on this negative to that bigger one, so it's going like that. Okay. Now, which one comes down more rapidly? I think this negative here comes down. Eventually it gets more rapid and it'll get steeper than that straight line that's actually constant. So there's going to be a point here and here where that'll be 0. So it's going to come, like it's going to go like this, and it's going to come back down. And then this one, because it goes down more rapidly, that's what a curve would probably look like, because it's pulling it down, like, because it's going down more rapidly. But at that point there, where they're both the same distance, that's where they cancel each other out, and that's where you get your 0 from. So that's f of x plus g of x. Okay. Alright, when you go on to sketch f of x minus g of x, so you want to sketch f of x minus g of x. Okay, so we've got f of x. Which one's f of x? So the f of x apparently is the line, and the g of x is the parabola. Okay, so if you want f of x minus g of x, that means that you have to sketch minus g of x first. So you got the line, which goes like that. When you do minus g of x, you're going to have the same thing, but it's going to be flipped. It's going to go like that. So when I add those together, so I add those two together, I add the two zeros, they get the same. I add this little bit onto that bigger bit, and I probably get it somewhere there. I add this one onto this one, and there is a point there where they are the same, and that's where it's going to come back. Okay, and then okay, so then if you look at that, sorry I went away, I thought I stopped the video but I didn't. If you add this one and that one, you get something a little bit bigger. Yeah, get that bigger, so that's why that's going up there. This one here, see, that will be 0, but eventually that will get more rapidly, like the parabola goes up more rapidly than the other one. So this is going to be like something like this. Okay. Alright, we do have f of x times g of x. So if we want to sketch f of x times g of x, so f of x times g of x. So when you look at this, you've got this. When you do f of x times g of x, what you need to do is you need to look at quadrants. So you look basically here. That's where you look at the intercepts. That's what it says. So you look at this side and this side. And this side's got will be a positive because you've got a negative times a negative because both those ones are below the axis. So that one's going there. This one has a negative and a positive. So it has a negative and a positive. And when you multiply those, you end up with your curve being down there. So your final curve, that one's going to be positive, and I don't know why I shaded down there because it's going to end up being a positive, should be up there. So your final curve, when you do draw it, will be here, and it'll be down there. And that's basically the red curve is what it looks like. So first of all, we're just going to do y equals f of x plus d of x for this one. So we have the cubic, and when we have this upside down, we have an upside down exponential graph. Okay, now the which one's which? Okay, so f of x is this one, and g of x is the cubic one. Okay, so if you want f of x plus g of x, wherever they intersect, then it's going to be double that y value. So this is double 0, so this one, the first 1 point will go there, that'll be one of the first points. Then if you look at this, another point will go there, so that's another point. Now, sorry, it won't go there, it'll go double that y value. So if that's x, that's the y value, then double that y value, because you've got this y and then another one, so that'll be there. That's the other one. This here, you've got a small negative, and then another one, so that's going to be here, because you're going to add on this little bit here. You're going to add that onto the end there, to that yellow bit, and then you form one that will sit there. So that means so far the curve's going that way. And then you just keep adding, like you got this bit here, so each, and then you got this bit here. So that means the yellow bit is going to add on to that, and it's going to leave, so it just keeps going like that. That's all good. Now when you come here, what you're actually doing here, you're adding on a yellow one, and you're adding it onto that blue one. Now at the start, when you're doing that, that's a little bit with a big bit, but there's got to be a point in there when you add that, and you add that, and they're going to be the same. So as soon as they're the same, that's where it'll cross the axis. So I'd say it'll go down here, come here, because that's still a bit bigger than that at that stage, and then it's going to come back, and there's a point where they're equal, and then this cubic goes up very fast. So that y value is going to get bigger than the equivalent y value for the straight line, because when you're doing that, you see it's going up really far there, see? So it's going up really far. So when you draw its y value, it's much bigger than its yellow equivalent, so it's going to keep coming up here and going very steep, and it almost like models the cubic. Very messy graph, but I'll just redraw that one there, and then this one here goes up more rapidly. So if you look at this, then that would be your curve. But it does hit back here before it comes back there, because it comes back there when those two spots are equal to each other. So the black curve is actually the curve for this graph. Okay, so that's f of x plus g of x. Now, once again, the f of x was the blue, that one, and the g of x was the g of x is the cubic. Okay, so now when I'm drawing f of x minus g of x, Then the minus g of x, you draw minus g of x first. That just means that when you're drawing that, your cubic line goes the other way. The exponential curve is still the same. That's still going to go like that. And now when I go to draw these, let's just have a look. So when you look at this, first of all, 0 and 0 is 0, so that's one spot. Then when you go look at these y values, there's going to be a point where they're the same. At that point where there's the same, that's where it's going to equal. But before that, what's happening here? I reckon this little one is smaller than this one here. Okay, so if you look at that one, and then in red, and then you look at the little one, so it's actually going to come up here. That's going to be bigger than what's going there. And then, wait a minute. Let me just reassess that one. Get it drawn properly. You do that. Okay, now the green one. The green one on the curve comes slightly over there, and that goes up there. Okay, and I'll put the axis on. Now I'm just trying to think what's bigger than that, but I'd say to go down here. The main reason is because that's just slightly smaller than that one, but also if you think of like a small number like a quarter, a half, and you cube it, you get an 8. But if you just go a half, which is what that one is, then it's just a half. So the 1/8 is actually smaller than the other one. So there's at some point where this curve will actually go below there. And then as we come here, the cubic goes up more rapidly than the other one. So even though that's doing that, the cubic is bigger. So it's actually like it's coming back up there. But it has a time where this part of it will go below the axis. If you look at this when you're adding, let's just get where they intersect, that will be, see that ends up being double that. So that means that the actual value will be there. So this means this curve will look like that. Okay, and further on that, now we've got to do f of x times g of x. So when you look at this curve, you've got this one, and then you've got this one here. Alright, so if you look at where the point of intersection is, that's where you're going to put it into two different regions. So this is like region 1, and this is region 2. Okay, now if you look at that, that's a negative y value times a negative y value. So it's going to be a positive y value. So if you're looking at an area where that is, that would be down here. No, it won't be down there. That would be up there. Because a negative times a negative is a positive. Yep, bad mistake. So that's there and that's there. And if you look on the other side, what do we have? We have a negative and we have a positive. So a negative times a positive is a negative. So that means that this curve will be down here. So when you draw your final curve, it's going to have to go up here, and then it will come down here. And what actually does happen, I would say it actually gets closer and closer it comes down here. So if you look at this, it'll go really rapidly actually, because you got this really rapid blue one times this green one, so it's just going to go really rapidly like that. So that's going to be your basic shape of your curve. Okay. Alright, the next one. So the next one we have this curve here, goes like this, goes through -4, goes through 4, and that point down the bottom there is 1 minus 2.25. So the actual 1 is down there. Okay, so that's at the point there. So when you're doing this, if you want to draw y equals the absolute value of f of x, that means that first of all, you draw positive, draw the negative. And then because it's equal to a positive, what you then do is you round out below. So your actual curve looks like that, and like that, and that's minus 4 and 4. Okay, alright, so now just going to do f of the absolute value of x. So y equals f of the absolute value of x. Alright, so what that means basically, it is an even function. So you need to ignore any of the graph that is on the left-hand side. So that's part of that graph there. And then you reflect it in the y-axis. So it's like that. Because when you put in a negative x, or when you put in a positive x, you get the same thing. So it is even, so that's why it will reflect in the x-axis. So it ends up being like that, and that's that one. Okay, then we've got the absolute value of y equals f of x. Okay, now that is outside the syllabus, but I will do it anyway, so it won't be in your trial, and I'm pretty sure it won't. Okay, so you've got y, that's way outside the syllabus. I think you won't worry about it, but it's you do y equals f of x, and then minus y is f of x, so y equals minus f of x. So you don't really have to worry about this one. So there's y equals f of x, and then it's y equals minus f of x, because it's this one, okay? And then what you've got to do is you've got to look for the restrictions. So the restrictions is on the y, on the f of x. So for this, you only draw the graph of f of x. The graph for f of x has to equal positive values. So what does that actually mean? That means that when we draw this, if we go back, when you go back to the very beginning, when you've got that equals f of x, before you even start, the f of x values would have to be positive, because no matter, even if you put a negative or okay, yeah. So the restriction goes right back on the f of x. So for whatever x values you put in there, it's always got to be a positive, because it equals the absolute value of y. So that means this part of the curve, even before you start, it can't exist, because you can't put in these values here. Like you can't put in, say, what's that number there? 4. Like you can't put in 1 and get, you can't put in x equals 1 and then get f of 1, and then you get like minus 4. That doesn't work, because it equals a positive y. So once you've done that, then you have to, once you've drawn that, then you go, okay, that equals f of x, and minus that equals f of x. So you have to draw the reflection of that other curve, so it'll look like that. But not in the syllabus, so I wouldn't worry too much. I think we give it a big scratcho. The next one you could be asked to do, because it's just applying 2 rules in one thing. Okay, so first of all, let's just draw it. If you've got this, so we'll do that first, that part of it. You just do it one step at a time. So that part of it, this part gets rubbed out, and then you reflect it in the x-axis. So you've got this, and you've got that. So that's y equals the absolute value of f of x. Now, if I then stick an additional absolute value on there, then basically the y equals, you draw y equals that, and y equals minus that one. Okay, so that means you've drawn y equals that, and then we're going to draw the minus one, which is that. Okay, and then once we've done that, then we have to rub out below, because it's got that absolute value there, so therefore the y value must be positive. So it's a really unusual looking curve. It goes like that, like that, like that, and like that. There you go. All right. Okay, so let's look at this one here. So we have this curve here. Looks like that. Oop, not quite. Better get that graph right. There you go, like that. And this one came down here. That point there is minus 1, 4. And this one here is minus 3. Minus 1, minus 4, and that's minus 3. And I don't know, what are these values? I think they're 1 and minus 3. Okay, so we're going to draw y equals root f of x. This is the flatten the curve. You can't have negatives, so it's flatten the curve, so it looks like that. So basically going to go like that, that's 1 minus 3, and that's your curve. Okay, so the y squared, you do exactly the same thing. It's just the only difference is when you do this one, you reflect it like this. So that's going to be 1, that's going to be minus 3. You reflect it in the x-axis. Okay, let's look at number 8. So with number 8, they're actually looking at copy each diagram below, then sketch the inverse function. Alright, so we're not doing 17 because we're not going to do the inverse function, and we're not doing 18. And yeah, we're getting into inverse functions here now again. Alright, so I just want to do those basic curves here. Okay, so really,